Audio with MXUWU. Presented by Shady, Maddie, Britannia, and Jennifer.
Sound is an oscillation in pressure. This pressure is usually caused by particles or stress on a particular matter that produces a vibration. The vibration is created by an object and propagates as an acoustic wave through an elastic medium of matter, such as air, liquids, or solids. To humans, sound is defined as the reception of wave frequency and the perception of sound in the brain. Sound waves are longitudinal waves that travel through matter. These waves are caused by a disturbance of energy and movement as it travels through said air, liquid, or solid. Sound waves travel in a droplet effect motion, resonating from the original disturbance in long waves, eventually reaching a point of blockage. Example, matter it cannot pass through. Analog wave patterns are smooth and continuous signals that change with time. The shape generally remains as a basic curve and are represented in a sine wave graph, a mathematical graph detailing a smooth oscillation, defined by y equals sine x. Analog waves can transfer from one medium to the next, smoothly interchanging between sounds, allowing frequencies and amplitudes to be recorded as they change. Digital wave patterns are different, however, as they have a distinct finite set of possible values and have a defined square and stepping shape to their graph. A digital wave pattern intakes a limited set of values and records at a consistent spot in time, separating different sounds at particular time. Volume is the degree of loudness, or the intensity of a sound wave. A sound can be interpreted as extremely loud or intense when within a close proximity to the origin of the particle disturbance. This is measured in decibels. Decibels are used to express the ratio of one value to another in a logarithmic scale. Volume is a useful tool in the industry as it allows users to control the intensity of the sounds. A particularly strong way volume can be used is in films. For instance, in intense fight scenes, music and sound effect volume are significantly increased, encapsulating the audience and enhancing the reality of the experience.
Frequency is determined by the pitch and sound of which the sound waves form. It is measured in hertz to record the rate per second of the amount of waves that are in the specific audio. Frequency is important in the multimedia industry as it shows the speed as well as the pitch of audio and how those two factors can change the impact on the audience/listener in music, movies, and other forms of media with sound. Mono is the most commonly used format for frequency in audio as it is a single channel or audio signal. This means whatever is outputted into one speaker will be exactly the same in other speakers. An example of this is with earphones with mono audio. The frequency and sound in your right ear will be duplicated into your left ear. The frequency for mono sound is a creative choice, but has a low frequency results in a powerful audio for the listener. Stereo is similar to mono, but instead has two channel audios, resulting in each speaker being able to output a different signal. In the example used in mono, with stereo, your right ear will sound different to your left ear if you were to wear earphones, as they have two different audio signals. The audio frequency range is between 20 Hz to 20,000 Hz for stereo. Surround sound is similar to stereo but has the capabilities of using 3 or more audio channels/speakers to work. It works by sending information through multiple channels. It's then used with speakers around a room to create an illusion of the sound coming from all directions around the room. The user. The most common range for hertz for surround sound is 80 Hz to 200 Hz.
Now, let's talk about sampling. Sample rate, or sampling frequency, is the amount of samples per given unit. This can be recorded per second or another arbitrary measurement. They are taken from a continuous signal, either discrete or digital. These signals are commonly referred to as time-domain signals due to the fact that they are measured continuously at stable intervals of time. They are commonly measured utilizing waveforms in the form of hertz or cycles per second. The common use of time-domain signals is to help aid in digital listening of analog audio, as the audio conversion is precise and is stable throughout to allow for crisp and precise digital audio to be created and utilized. Hertz are excellent for recording sound as they can show the differences in decibels from audio between different parts, allowing humans to manipulate audio within post-production to keep the audio consistent, allowing for ease of splicing audio from different instruments to be the same level. There are many sampling theorems which are used by SFX engineers to ensure that the audio is precise throughout. The most common theorem is the Nyquist principle, or theorem. This that states that for a perfect reconstruction of a signal to be possible, the sampling frequency has to be twice or greater than the maximum frequency of the signal being sampled. They elaborate upon this and exclaim that if the audio signal has an upper limit of 20,000 Hz, which is approximately the upper limit of hertz of a human that we're able to possibly hear, a sampling frequency of 40,000 or higher would avoid analyzing and will allow for perfect reconstruction of analog audio. However, the most common audio recording is 44,100 Hz as is industry standard and follows the 2020 rule, but is above to be compliant with the standard instruments for recording, which record at 22,050 Hz. This allows for moderate filters to be used to analyzing without much audible effects. As time has progressed and technology has become cheaper and cheaper, companies are now using higher sample rates, such as 48 kHz or 88.2 kHz or 96 kHz and others. This is primarily due to the technological revolution, with speakers allowing for professional audio from 48 Hz, as it even has more buffer room before filtering is required. This still utilizes the Nyquist theorem or principle and is commonly used by scientists and film creators to allow for absolute perfection when recording audio. The sample size of audio is calculated by bit rate times sample rate. This value is usually measured in megabits per second, but can be measured in an arbitrary number. A bit rate is simply the amount of data per number measured. It is usually represented as a static value of 8-bit, 16-bit, or even 24-bit, or can have a variable bit rate which changes depending on the usage. The increase in bits results in an increase of quality. However, depending on the medium used, file styles can vary in length, primarily due to compression algorithms employed to ensure that the files are lower without losing significant quality. This only applies to PCMI sampling because lossy formats like MP3s aren't exactly going to be higher quality for a larger file, as it doesn't accurately depict the quality. Different variations in bit depth are utilized by different mediums. For YouTube, due to the lossy compression, it would be completely fine to use a 16-bit audio when uploading, primarily due to the algorithms in place, which will diminish the quality of audio and video. For 24-bit, it is mostly utilized when working professionally, such as working in a studio for making music, primarily used by SFX engineers, as it allows the audio to be altered and manipulated and then compressed to 16-bit for commercial release without losing that much quality. In essence, the whole entire idea of making something 24-bit would be for professional use, so whenever you convert it back to 16-bit, it is the highest quality of 16-bit. For audio sampling, there are different variations you can use. Most commonly 8 and 16-bit are utilized on the internet. Less commonly is 24-bit, primarily due to the fact that it requires high quality headphones to use and won't work properly with streaming services due to the file size that 24 audio brings. These different variations in bits highly impact upon quality, with 8-bit being less and less due to its limited quality and being outdated, and 16-bit becoming the new norm with videos, especially online. 24-bit, as I mentioned before, is only really used by professionals within the studio. They normally record at 24-bit and export to 16-bit to improve the overall quality of the audio. This is because if they recorded at 16-bit and through editing made it even smaller, it would not work within the 16-bit format. Hence, they ensure that the piece is recorded at 24-bit and then converted to 16-bit within post-production. On the screen, you're going to be able to see 8-bit and 16-bit audio, and you'll be able to hear the difference. And here's 16-bit. As you can see, there is less white noise in 16-bit and there is more higher quality in 16-bit. Primarily because 16-bit can be converted to 8-bit. It's like trying to squeeze something into a hole. Sure, it fits, but like you can't fit everything. So what happens is the 8 bits that are left out just basically vanish and it becomes white noise. Those parts don't actually even retain audio.
Different types of audio file formats. Audio file formats is a format used to store audio or music in a computer. The 5 different types that will be explained are MP3, WMA, AIFF, WAV, and MIDI. MPEG-2 Audio Layer 3, also known as MP3, is a lossy compressed audio format. This audio file comes in a small size, made convenient for saving up space. MP3 audios are compressed as much as possible while still trying to sound close to the original. They are good for storing music in phones or iPods. Windows Media Audio, or WMA, was made in response to compression issues that MP3 struggles with. It is owned by Microsoft and is said to be better than MP3. Despite being a better quality than MP3, WMA is still not as popular but is a better option for a higher quality audio. Audio Interchange File Format, or AIFF, is the main format used by Apple computer systems, made by Apple for Mac and largely intended for Windows. They're an uncompressed audio format, which means they take up more disk space. They can also hold different types of audio. WAV audio format, or commonly known as WAV, serves as a container for various audio formats. It can contain both compressed and uncompressed audio. High-resolution WAV, or high-res, is a high-quality version of WAV. They are uncompressed, meaning they come in a huge file size, but they have great sound quality. Musical Instrument Digital Interface, also known as MIDI, connects devices that make and control sound. These include synthesizers, samplers, and computers. MIDI works by communicating using MIDI messages. They let one keyboard trigger sounds on a different synthesizer. MIDI makes it easier to record music and edit notes.